said, my name is Magnus Hagander, for those of you who don't know me. I see a lot of familiar faces and a couple of non-familiar faces. I work for a company called Red Pill Infra back in Sweden, as said. We are an open source services shop where I lead up our Postgres effort. Within Postgres, I'm part of the core team. I'm one of the committers. I'm on Postgres Europe. I'm in a whole bunch of other little circles in the Venn diagram. But in the context of this presentation, I'm also on the Postgres infrastructure team, or PG Infra, as we're often referred to. So that's what we're here to talk about today. We're not actually here to talk about Postgres. We're here to talk about Postgres.org and the things that we do that hopefully helps. The idea is that we help the Postgres project itself, and a few of the details around that people might not be aware of. There is obviously a lot more to cover, but we'll do a quick 25-minute run for it. So who is this PG Infra thing? Like, we're hidden behind secret email addresses, which happens to not actually be PG Infra. So if anyone wants to contact us, then we're sysadmins. Because we, oh man, did I just say that on a recorded talk? It's not very secret anymore. Okay, we're going to change, no. So we'll stick to that. So the PG Infra team today consists of 7 people. I think we have briefly been less, but we've been around 7 people for a long time. We're from 6 different companies. So one company has 2 people. And in total, we have a dedication of 0 hours. Like most Postgres things, right? We're volunteers. But I think unlike a lot of people, when you look at the development of Postgres, the people who are writing the code, a lot of them are actually employed to write Postgres code. To the best of my knowledge, I should say, none of the people on PG Infra is actually employed to work on PG Infra. Some of us have at least told our managers that we're doing it, and sometimes even on work hours. I can't speak for everyone. Maybe someone didn't tell them, so officially they never do it on work hours, right? But fundamentally, we run basically all the services that hide behind a PostgreSQL.org or related domain name. And we try to do that at 0 hours. Obviously, you can't do it with 0 hours, but we try to get it as close as possible while still maintaining a certain service level. So simply, how do we do that? Well, we try to do our best, as all infrastructure engineers, to automate ourselves out of a job because we didn't have the job in the first place. So automating ourselves out of it is even more important. We automate almost everything. We work hard with making sure our services are what we call conformant to our platform. We have a thin layer of management on top of Debian. We run just Debian because running more things means more work. We do enforced config for most things. Where we don't do enforced config, we at least do tracked config. And if we have software that does not run under these circumstances, we don't run that software. Right? Sometimes we try to help fixing that. And the real thing to make this work with such a small team is to avoid exceptions at any cost, almost. Like, it has to stick to this level. So what do we mean? What are our services? I mean, there are some of these that I think most people, particularly here at the developer conference, will have interacted with at some point. As anyone know, Postgres has a website? www.postgres.org. It's there. Actually, we run 2 separate Git management servers. Actually, not true. We run a lot more than 2, but we run 2 that are not just for PG Infra. One of them is the git.postgres.org, where you can find the anonymous Postgres Git mirror and a whole bunch of projects related to Postgres. We also run a hidden master server just for the Postgres itself, where only the Postgres committers have access at all. So a different security level that is then mirrored out. We handle the majority of the downloads for Postgres. The only exception is the Windows downloads, which are outsourced. Couple of mailing lists, many emails every day. Mailing list archives going back 30-ish years. Every single email ever posted. Still available, still searchable, still reachable. We have a wiki. We have the Postgres build farm that runs our build tests. We have the commit fest management. We've got all of those things. We also have a whole bunch of other services that people may not have been in. For example, we run the machines that do the release building. Both when we do an official canonical Postgres source release, someone builds those tar files, verifies the contents and all of that. That runs on our stuff. We have the build machines for apt packages for Debian, for Yum and DNF and Zip, for Red Hat and SUSE, etc. We run code coverage tracking. We run Coverity, static analysis. We run a bunch of different instances of conference management systems. For one thing, for this conference, for Europe, for a conference in Asia, for the US, for a whole bunch of them. This is where automation pays off, right? It doesn't really matter how many we have. We have fewer now than we had for a while. It goes up and down. As long as things are all the same, it goes through. Right? We have a second list archive for all the things that everyone can't see. We have a whole bunch of internal lists within Postgres that has, security, the security team lists, things like that have security restrictions on them. We need to keep those. We're on Planet Postgres. We're in the wonderful business of email delivery. Anyone who's ever worked with that knows how fun that is, right? We host mailboxes. Like you can email something at postgres.org or at pgevents.ca or at postgres.us or a whole bunch of these Postgres-related domains that all come in through us. And of course, nothing works without DNS, so we run DNS. And hopefully it doesn't break it, but we all know about DNS, right? So there's all these services that some of you probably have seen, some of you probably have used, many of you have not. And we've chosen in the Postgres project to go basically as much as possible with self-hosting. How is that a good idea? Somebody else could run this for us, right? A lot of these things somebody else could run for us. It used to be a very, like the argument today, if you look at it from a developer perspective, which we're at this conference, right? A lot of people are going like, why is Postgres not developed on GitHub? Right? And some of us, are old, so we still remember when the exact same thing was said about SourceForge, right? It was that they are never going away, and everybody uses it, and if you don't use them, you will soon be irrelevant. And, well, I don't know, is there still a Postgres project that uses SourceForge, I think? For a long time, Barman was on SourceForge. I don't know why. Because they were on, I think they started using SourceForge after SourceForge was to most of us dead. But all in all, Postgres, so like right now we're at that, we have GitHub, we have GitLab, we have, whichever. There's always going to be more options of these. Yes, I do agree today that it is highly unlikely that GitHub will go away. It is highly unlikely that they will go the way of SourceForge, which hasn't actually gone away. It's just terrible. And they started injecting things into people's downloads and stuff, and we should have stopped using them long before that. I don't think that's going to happen to GitHub. I really don't. And same thing can be said for a bunch of the other services that we run. Like why not just let somebody else run it? But there are still a number of reasons other than the fact that they might go away and they might go evil. Yes, there is the idea that we maintain control, right? That's for good and for bad. We maintain control, we also have to do something. Nobody else will actually do it for us, so it does go both ways. We get a more predictable availability because we own our own data. Becomes extra interesting because just like the Postgres development group, PG Infra isn't actually a formal organization. So data ownership is with something that doesn't exist. And it turns out in a lot of ways, and we've even heard that from lawyers, surprisingly enough, that's a good thing. Right? Because nobody can walk away with the data. No company owns the data. If they shut down, it's gone. Or, lucky you get a tar file with plain text in it, and that's 14 million emails or something, right? We own the data. And it comes also down to things like end user services. Just the other day, I mean, the classic here is access to our websites, access to our documentation, access to our download from countries that happen to be embargoed by whatever country that the service provider is in, and you can't get it. You go like, yeah, but no, it's not that common. We had a report just the other day through one of the external service providers we have where people couldn't get to the data because they were blocked in Barcelona. So, it's not just these countries on the other end. Well, from here, I guess Barcelona is on the other side of the world, but, it's not everywhere. And as long as we keep control of where our data is from, we can maybe not make it available through the same way, but we can make it available some way to our end users. And we can ensure that we provide a level of service to them. These are sort of the core reasons. These, I think, are the main reasons why self-hosting still really makes sense, even when we believe that these third parties will actually still be around and won't turn actively evil. So what do we actually run? Let's see a couple of things about what we do in numbers. This, I think, is still correct, because this was correct about a week ago, and I don't think anyone has done anything more or less a week ago. So this PG Infra numbers, we basically had at the time 13 servers. They're distributed across 4 different hosting companies in 5 different data centers in, I guess, 4 different countries. The idea, again, being if we lose an entire provider, if we lose a data center or something, yes, we will lose like everything we have is not data center redundant. It's not. But we have the data, we have our backups, we can bring it back up within a reasonable amount of time, even if we lose permanently a complete data center. Currently we use one infrastructure cloud. We run a total of 67 VMs, and then we do have some services that are service providers run, but we run them in a way that we know that we can back out of them or replace them if we have to. Now, actually, that's not a week ago, that's 2 weeks ago. A week ago, that changed. Because suddenly we had 9 servers. And we only had 3 hosting companies and 4 data centers, because one of our hosting companies decided to shut down their service. Now, in fairness, we knew it. We had a little bit of warning. We had a warning at the end of last year. They told us they were shutting down the service at the end of next year. And then in February, they told us, oh, by the way, since you guys are on the free plan you're not paying for, we're shutting you down at the end of March. Or was it the end of April? End of April. End of April. We were like, oh, so now we have like 2.5 months to deal with what amounts to, a third of our servers and some of our most powerful infrastructure. So we did. We got it sorted, I think, 3 days before the deadline, something like that. So it did work. The idea of this multi-provider, multi-data center thing did help. They would, in the defense of them, they would let us continue to use their service. We just have to pay for it. And I think we ended up having our IP addresses for like 2 extra days because we couldn't figure out how to delete them. And that's like $100. So, which I don't think we're going to end up paying in the end. But like these are realities that happen. So we do need to over-provision. We need to be ready. These things actually happen. So let's talk about some of the actual servers. Like our website, a lot of people would go like, our website is not particularly redundant, right? We have 3 front-end servers, 3 caches, 1 server, and 1 Postgres, right? The Postgres website isn't actually very big. Like, it doesn't take a lot of hits from these kinds of perspectives. We don't need more than 1 VM. I think we have scaled it up to have 2 CPUs on the virtual machine. It runs both Nginx and Postgres on that one. And yes, we run Postgres 15. It's still supported, because we don't do anything all that much. So the Postgres website, actually, just as a number, we take about 80 to 100 hits per second on a typical day, not counting release days, on just averaging out on any day, about 150 megabits a second. We peak upwards of a gigabit. Unusual, but it does happen. We do get a cache hit ratio that varies between 85 and 99%. And we are looking at about 275,000 active URLs on any given day. So to say, from the perspective of this hosting, that's not actually very big. That doesn't need more. In fact, the fact is we certainly wouldn't need 3 front-end servers to do that. We could easily do that on a single machine. We do it across 3 machines for the data center redundancy, right? And this part also gives you the thing that you might have seen that comes out of this, that you see as end users sometimes. You've seen this Guru Meditation 503 internal error on the Postgres website, right? That happens when one of the front ends can't reach the back end, and we only have 1 backend. But having only 1 backend makes life so much easier. And this doesn't happen all that often, right? And the idea is, as long as the content you're looking at is actually cached in the front end, you won't see this. But one thing you will see, for example, is if you try to log in and this happens, then you can't get through, and it will happen, right? Because right now, our front ends are located in Salzburg, in Oslo, and in a city in Texas that I can't remember which one it is. But it's in Texas. And the master is located in Salzburg. And if the network between the data centers go down completely, and that's just public internet, then you will get this Guru meditation. If this happens, give it a little bit of time. Normally, those networks come back up within 5 minutes, and everything is back to running. So that's probably the most exposed part of this multi-data center thing that you as an end user will actually see. It has happened that there are worse things that show up like this as well, and then we have to work on it. But most of the time, these things resolve themselves before we even have time to do anything serious about them. The other big public service to note is, of course, the ftp.postgres.org, which is the same as download.postgres.org. We just used that name for the RPMs, which is also the same as app.postgres.org, which is what we use for the Debian packages. And these are the main things that go through this. This is one of the things that were hit the hardest by this data center shutdown, because that took out 50% of our capacity to deliver downloads, because they were on fast machines in fast data centers. So we used to have 4 machines, and it's now down to 2 machines. But at the same time, we moved the downloads over to a CDN. Some of you noticed there have been some issues around the latest release, where some files were out of date for a bit. That was a bug in the CDN synchronization script we had. And of course, again, this release happened a few days after we had to do the switch on a very tight deadline. So that did happen, but it didn't go. So some numbers on that one for the interesting. We get about 66 million hits on the download sites every day, roughly 750 per second, enough to matter. There are some interesting metrics for those who are going for it. Like we get 16 million hits to the apt repository, 47 million hits to the yum. But if you look at bandwidth, it's 2 terabytes to apt and 1 terabyte to yum. So there are a lot more hits to yum than there are to apt. And when you look into it, that's because apt is just way more efficient than yum in network requests. Like even checking that there are no changes produces a lot more requests to a yum repository. We do in total about 10 terabytes a day. For those interested, comparatively, that means we would blow through the Amazon free tier in around 2 hours. So it is a fair amount of data. It's not a huge amount of data, but it is enough to matter, right? It's enough to make, if you run that off 2 machines only, it starts being quite noticeable. You will also notice that we're doing 10 terabytes a day, and only 3 terabytes are apt and yum. Yeah, the things that we do host that are big, we host PostGIS, we host pgadmin, and we host the Postgres source downloads. We also have all the, for those who, like me, are old, remember things like PG Foundry and Gborg, like all the downloads from those sites from back when they were decommissioned, I guess 20 and 30 years ago, respectively, or something like that. All those downloads are still there. Pretty much only bots will download them. But bots are not smart. So they will download them over and over and over again. And just one thing, I was going through a couple of these just to prepare this presentation and go like, okay, so which are like most resource consuming? Postgres build farm takes about 5 hits per second. Like that's nothing for a website, right? It does 33 megabits a second on average. Those are some seriously big web hits, but that's because what it does is pushes up a whole lot of Postgres build logs, and those logs are big. So speaking about, what about Postgres? Like this, don't you guys run any Postgres? And yeah, we do, but we're really boring with our Postgres uses, to be honest. We have 32 instances of Postgres. Only 7 of those average more than 1 transaction per second. 1, right? The website does 3. The wiki does 30. List archive does 50. The list server is kind of interesting. It averages something like 3, but it peaks at 800, 900 transactions per second when large emails are delivered in parallel. But still, like for those of us who run Postgres servers, for a living, these are not particularly interesting numbers. Like our Postgres usage is not cool. And we don't do anything fancy with it. I think the only Postgres extension we actively use ourselves is pgpartman, the partition manager. 32 instances, 3 of them are bigger than 10 gigabytes. Everything else is small. Right? In fact, list archives is only 18 gigabytes. That's also pretty small. And then you have the build farm. And the build farm also has an archive with historical data. And that's the only one that's really big. Right? It's sitting at about 15 terabytes today. So what we do with Postgres really is not that interesting. Hopefully what we do for Postgres is the interesting part. So most of this works pretty well. What's painful in what we do today? Well, I see there are a couple of people here from our PG Infra team, so you will all know exactly what I'm saying when I'm saying enterprise hardware. We have a single piece of actual enterprise hardware in our infrastructure. It's a Cisco ASA firewall that fronts one of our data centers. We do reboot it once a week, at least, to keep it working at all, right? It is currently being replaced because most of the time when you're seeing a PostgreSQL.org service that's just insanely slow, or you can't reach the Git server, which is behind that one, or you get these 503 errors, I'd say 95% of that is this one thing that's in front of one data center that holds 4 of our servers. That is definitely a pain point. It is being replaced. We have a new one that's being worked on. I think it's almost ready to actually go in action. So hopefully that will make things better. But that's one of our biggest pain points. Another huge pain point really is MediaWiki. I'm sorry if it's not fun. Like, it's terrible software to run. It is so horrible in many ways. Like, maintaining it's really bad. Performance is bad. Upgrades are. I think we spend more time upgrading MediaWiki to, like, when we upgrade to the next Debian version than we spend upgrading all the other machines in the infrastructure together. It's at that level, except for maybe one thing, and that's Redmine, which is also approximately equally terrible. And the thing that we've gotten recently that has caused us a bunch of pain is all these wonderful AI bots, right? Because we used to have the search engines, and they would download this robots.txt that said, don't index this thing, or do this or do that. And they actually followed those rules. None of the AI bots do that. Why would they? They're AI. They can do what they want. Right? So we're seeing them regularly these days. They're taking out the wiki, basically, because they're flooding it, and MediaWiki is very, very slow. They're just flooding it with requests for irrelevant data. And unlike most search engines, which come from recognizable and easily handleable IPs, I think we had one going. The other thing they tend to hit is GitWeb. We have one going for GitWeb. They hit us from about 20,000 IP addresses, completely distributed across different Chinese clouds. And we did eventually figure it out. It was one of the AI bots from there. And we're not the only ones. You look at other open source projects, like AI bots are a very serious problem when they're hitting anything that cannot take at least 20, 30 hits per second. The wiki can't do that unless it's cached data. Not even close. GitWeb can't do that. CVS Web can't. Like, these services just cannot do that. It took out, I think we ran GitWeb across 16 CPUs. It still cannot take 20 hits a second. It just can't. Unless you only do the cheap pages, but of course they hit everything to build up their data. So AI bots are an actual real problem. So if someone can figure out how to just, kill them, then please do it. Like, you don't talk to us first, just do it. Don't kill the operators of the AI bots, kill the actual bots. So to wrap this up, as we're pretty much done, what can you do to help us? What would we need? What would we need help with contribution-wise today? Well, at this point, we could actually really use another data center because we just lost 3. What we're looking in for those we're looking for dedicated hardware because we want to run our management platform on it because, again, conformity, we want everything to behave the same. It needs to be unmetered bandwidth. We just don't have the cycles to move things around based on bandwidth requirements, and we need native IPv4 or IPv6, no carrier NAT or anything like that. If you are in an organization that could help us provide that, please contact us. We are very interested in being able to expand to at least one more data center, preferably at this point one that is not in Europe. So either North America or Asia are where our weak spots are for these things right now. So I think I got about 15 seconds, so I'm quickly going to bump into this one, which is another question that we get a lot of time, which is, can you just run this for us? Like, you should run this for Postgres needs this. Please run it. And the answer to this question is general rule is maybe. Right? It comes back to what we said at the beginning. How do we make this work? Well, for one thing, if the software that you want to run does not have a properly maintained stable version, we're just not going to run it. Right? If it's one of those, in order to security patch this, you have to upgrade and add 14 new features and reconfigure 27 different things that are in the new version, then no, we don't have the resources to do that. We prefer if it's like Debian packaged. It doesn't have to be. We prefer it because it makes our life easier. We have a couple of exceptions outside of this that we run now. Some of them we run across many servers, so we certainly do it, but we'd like to avoid it. And it needs to support some level of automated patching. Like I've had software suggested where patching involves, oh, every time you have to go in and edit this config file manually and do no, we can't do that. The other thing that we need is a long-term ownership within the community. If you want us to run something, well, running it is one thing, but then somebody has to maintain sort of the insides of it. Like we run the wiki, but we also have people who maintain the content of the wiki. And we need a commitment to do that because somebody has to do that. The amount of time spent, for example, when, as the example again, the PG Foundry was shut down, or actually when it was shut down, it was fine. The years leading up to the shutdown, when all the people who set it up and were supposed to maintain it didn't maintain it anymore. That was many hundreds of hours going in from people who didn't really care about that part, but it has to be maintained. You can't run software facing the public internet without maintaining it. Like that will shut down everything else. But if you can fulfill this, like if it's a service or a product that you think is good for the Postgres community, that you or preferably more than one person are willing to take sort of the high level ownership of over a longer period of time, and it has a working release kind of structure, then we are absolutely open to running these things. So please contact us and let us know. And we're there. We're there to provide the services that the developers and the users of Postgres need, right? We do also run a bunch of services just for ourselves, but primarily we run them for the developers and for the users of Postgres. So I guess I'll quickly skip by this one because I am out of time and you all want lunch. So what I'm going to say is I will say thank you for listening. I'm happy to stick around for some more questions afterwards, but the rest of you I will release to go have your lunch. Thank you very much.